In this problem, we're asked to find the center of mass of a person who has these measurements. The main idea behind this problem is using the center of mass formula for a system of particles, the particles being, in this case, the individual body parts. To simplify our calculations, we will make use of these two facts. The first is that because the person is symmetric, the center of mass will lie somewhere along this axis of symmetry. With this information, we won't have to calculate where in the x direction the center of mass is, and we'll only have to worry about where it is in the y direction. The second fact is that we can treat the center of mass as being in the middle of each body part, because in the problem statement, we're told that the person can be thought of as being composed of uniform solid blocks. So for the example of the person's head, which is 20 centimeters wide, we can say that all of the mass of the head is located here in the center. If we treat each body part as a particle at its center of mass, we now have this system here composed of 8 particles, each of which has this distance away from an origin that I've set up here. With this coordinate system, positive x is to the right and positive y is down. This is arbitrary, but it will make the calculation simpler in the next step. To finish the problem, we apply the center of mass formula, which is 1 over the total mass of the system times the mass and the position of each individual part. So, in this expression, I have mr for the head, mr for the trunk, 1/2 m for one arm, 1/2 m for the second arm, and similarly for the 2 thighs and the 2 calves. Then we substitute in the values given in the problem statement and evaluate to find that the center of mass is located 72.1 centimeters below the person's head along the axis of symmetry.